All right, welcome everybody to our aerial robotics community group. Today is Wednesday, October 9th, and today is a community meeting with a presentation by Aaron Boo. So my name is Kimberly McGuire from Bitcraze. Ramon is from Drone Code Foundation. Unfortunately, he is absent currently because there's an unfortunate, he has to go to the vet with his dog. So hopefully he'll be able to catch the last part of this meeting. But let's just continue. So the agenda for today is this. I'm just going to have a couple of small announcements. Then we're going to have the presentation by Aaron. After that, we're going to have some updates by the community members and also kind of like the updates of the aerial robotic landscape. Also, we'll have a discussion about the structure of our meetings because me and Ramon, we had some thoughts about that we would like to share. And then some concluding remarks and the planning for the next meeting. So yeah, some first announcements. So ROSCON Odense is going to be in 2 weeks, 1.5 weeks. Fortunately, it's already sold out. So if you haven't had a ticket yet, that's unfortunately too bad, but it's also very last minute then. But we are going to have an aerial robotics ROSCON meetup for anybody that's going to join. The app for the conference is not out yet, but we'll set up a meetup event in there. But I've already started a ROS discourse. At least I will just very quickly share that on the chats so that you can also see that as well. Just one moment. Did I? Yeah. Doing two things at once is always very difficult to do. Yeah, it's in the chat. So just give a thumbs up if you're planning to come. It's going to be a Storms Bocuse, which is a huge food hall with a lot of bars and a lot of food. If you haven't had food at 8, you never know. And first drinks are going to be on me and Ramon. And also, if you're not able to make it, there are other ROSCONs out there. Like the ROSCON Germany is planned for December 3rd and 4th. And ROSCON India is going to be on December 5th and 6th. So no problem there. But first up is going to be a presentation by Aaron Blue, and he's going to talk about an overview of Raven 1. I'll let him talk about all the details about the gimbal and camera control. And he's from Couloir Labs. Yeah, I guess you're going to do more of the introduction, so I'll just unshare my slides, and then you can try to share your slides.
Perfect. Well, thank you for having me, Kimberly. I appreciate you setting all this up. So give you a quick background on myself and the company, and then we can kind of go into sharing a little bit more about the gimbal. I'm Aaron, and I'm the CEO of Couloir Labs. We provide systems integration mostly for NDA compliant UAS. So we have a couple different partners that we work with. And what we're trying to do with this effort is provide an open source gimbal platform that can be integrated with PX4 flight controllers and leverage MAVlink as well as other open source software like ROS2. So I'm going to give you guys an overview of the entire product. And this is kind of the first public unveiling of some of these details. So I'm very excited to get your guys' feedback. We've got a couple different platforms that we're working on, but today we're going to focus on the EO IR combo gimbal, which is an electro-optical and an infrared combination. So I'm going to just go ahead and
Aaron,
jump in. Go ahead.
Just double checking. Did you share your slides already?
No, let me share my slides.
Okay, yeah. I was afraid that it didn't work out, but yeah.
So I'm going to go through a quick little slideshow, and then I'm going to jump into the spec sheet for the gimbal. So let me go ahead and share my screen. 1 second.
Do you need some help, Aaron? Or are you just...
Always.
So if you select the share button on the bottom, like in which browser are you using? Are you having the meet in?
I am in Chrome.
Oh, that should definitely work.
Yeah, it'll just give me one quick second. I think we're good.
Ah, there you go. Perfect.
Okay.
Yes.
Go on the slideshow real quick. So this is a very brief presentation. I just wanted to brief the company real quick. Again, this is an overview of Raven 1, which is a S.W.A.P optimized, standing for size, weight, and power, electro-optical and infrared gimbal with ROS2 Foxy base installed. It's also got MAVlink support for gimbal and camera control. So as we talked about a little bit, we're dedicated to building dual-use drones and gimbals in the USA, and our main customers are system integrators, OEMs, and developers. We are headquartered in Durango, Colorado, in the United States of America, and we provide a couple different items within products and services, focusing on custom UAS design. We also have some really good electrical engineering resources for custom PCBAs. Custom gimbals is a big one that we've been working on for about the last 16 months, heavy R&D. And we have a FLIR Boson Plus thermal integration with their 320 and 640p. So if anybody needs help with any of that, we've got a wonderful integration with Modal AI, and they've made all of this effort really seamless through to ROS2. If you also need help with any product management or consulting, if you're working on a new airframe or a new integration, we're happy to help. So what is the Raven 1? It's a 3-axis stabilized camera system. The weight currently is about 450 grams, and we're working on a fully encoded version that's going to be a little heavier than that, but the final weight's going to be around 500 grams. It's got onboard video processing, and as I mentioned before, it's got a 640 pixel Boson Plus low wave infrared. It's a very nice infrared sensor, and that's running at 30 hertz. It's also got a 4K image sensor, MAVlink V2 compatibility, and ultra low latency video feed. The video feed's pretty clean. It's just any RTSP stream. Anything that can accept an RTSP stream is good to go. It's going over essentially a UVC connection. So quick little block diagram here of just what we're working with. This is the actual gimbal system here. There's a USB-C interface where you can access a companion computer, which is actually running ROS2. And then there's a data and power connection that goes into the drone body, or if you're running a robot, whatever you have that you've installed this on. And then we've got a couple connections coming out of our data. There's 2 telem ports that are required for this integration. And that's how we're going to actually integrate with MAVlink and then eventually with ROS. The image stream is up here on a USB 2.0 connection that in this use case is going to an Ethernet converter and then being passed into essentially an RJ45 jack or a interface that's a UVC interface on a video transmission device. So this is a quick block diagram. We have a few sample images here. I just wanted to show you one of our integrations on a HereLink. These are streams from a very similar vantage point on the bottom here with a 4K camera. We then have an 18-degree high field of view infrared here. These are both Boson Plus images here, and this is a 32-degree. So much different field of view. We have integrations available with all of those. In terms of MAVROS, we're leveraging the Voxel 2 SDK, and they have a bunch of wonderful development packages that allow essentially the topics to be output into ROS2 messages. So depending on the gimbal format that you are working with, you'll have options to interact with these different messages. In terms of the EO-IR combo, it's going to have a high-res camera on it. So any of these high-res topics can be subscribed to. And then it also will have the thermal topic that it should be able to subscribe to. That's a newer sensor that's in beta, so it's not defaulted on this list. And I believe that that is supported. I haven't done a whole lot of ROS2 work on this product, so excited for everybody to try it out. Other than that, there's a lot of other things you can access within here. If you get a gimbal that has a time of flight sensor, you can get an entire point cloud and all of the topics to interact with the different messages for that. In addition, there's MAVROS integration. You can probe PX4 via ROS2. And then this allows you to actually interact with the flight controller using the gimbal. So that is a quick overview of kind of what the gimbal is at a very high level, how it interacts with ROS, and just kind of an overview. And then I have a specification sheet, but I was going to maybe pause really quick for any comments so I can drill down on any of the specifics. Does anybody have any immediate questions or comments before I proceed with the specification sheet?
Yeah, I got a question.
Go ahead, Andrew.
Yeah, the streaming, are you just using the HearLink transmission system for digital video?
Yes, sir. Yes,
Okay.
sir. For this use case, we are, and it's also compatible with the similar interfaces like a Doodle Labs radio, where it has that USB for the video in.
Okay. Is it through the RJ45 you were talking about?
Yeah, exactly. Exactly.
Okay.
And I can bring up the spec sheet, which has some details on that exact installation, Andrew, if you're
Okay.
curious.
And then the other question I had was the ROS topics. Have
Yes,
you worked
sir.
with the encoded formats? It says the raw image formats are a little hard to work with, especially if you're trying to stream it.
Yeah, this gimbal has everything that Modal AI offers in terms of all their image formats. So any of the encoded versions, any of the compressed H.264, 265, and the raw formats are also available, I believe, in the NV12, if I'm speaking correct off the top of my tongue.
Okay. Okay, great. Yeah, I was just wondering. Yeah, just not sure what the ROS topics would be used for, but I guess maybe, I guess talking to the Voxel 2 or something.
Yes. So that's a great question, right? Like this whole ROS land, a lot of times it's kind of a wrapper that's maybe a little bit more than you need because you can use native processes like that are already interacting with MAVlink, like Mav SDK, for instance. I can see that being possibly a little easier to interact with this, but the ROS messages are also available to publish, for autonomous flight, right? So you can run like the figure 8, for instance, and actually use Voxel Vision Hub to interact with these ROS messages. Now, I don't think it's ideal, but in a use case where you maybe needed to publish those messages for use on other ROS applications, that could be helpful. Anyhow, anything else, Andrew? Sorry to just blabber.
No, that's all I got.
Okay, let me share the spec sheet and we can go into the details. This is a preliminary spec sheet that is quite early in terms of being a V1. I'd say we're probably in our alpha stages. We're starting to release it and look for testers. If you guys are interested, we very much are looking for people who are looking to integrate with this. Being an early beta tester, definitely have access to driving some of the requirements a little bit. So I'm going to go through where we're at, and feel free to interrupt me. I think I talk a little quick, but if you have any questions, please interrupt. Okay. So this is a little bit of an overview of some of the preliminary specs on the pitch degree of freedom, roll degree of freedom, and yaw. We are working on an encoded version that'll have a 14-bit absolute encoding. And right now we're running on a dual IMU setup for the control theory. For RC control, we've got MAVlink Gimbal Protocol V2 or PWM. We may drop PWM off of the spec sheet because it does not allow for gimbal control while you're running PWM. And the nice thing about the gimbal protocol is that it allows an RC pass-through. So it's much more powerful than just a PWM. And so we may drop that to the wayside. Camera controls with the MAVlink Protocol V2. And then this is all powered by a Qualcomm QRB5165. Very powerful single board computer. Has TensorFlow Lite on board. Also has MAV SDK, MAV ROS, and a bunch of other great stuff from Modal. As I mentioned before, the thermal image sensor on this model is a 640p. It's got 30 hertz. 30 hertz is really awesome. They said they're going to be offering a 60 hertz version, and we do have some vendors with a higher frame rate. So if that's something that anybody's interested in, we can definitely talk about that. Here's some of the different image formats with some of the bandwidth. The thermal is going over raw, so it's pretty heavy. But if you come down to the actual FPV sensor on this, it's extremely low. So very, very efficient bandwidth on this guy. If you're trying to do really long distances, like 80-kilometer flights with Doodle, you'll want these lower bandwidths, and you can always turn off different sensors to reduce your bandwidth. Here's some specs on the power consumption. Because it's using a Qualcomm chipset and not like a NVIDIA, it's only got 35 watts of power consumption at rest about. Approximately 50 at peak with current testing. And then we're also working on some different mounting and vibration isolations solutions. Currently, we have a couple different options, but we are compatible with the Pixhawk payload bus standard, which allows you to connect to like Astro's aircrafts and anybody else who has those mounts. Repeating through a bit on this block diagram, but we have a couple different components here. We have the gimbal, which connects to an isolation or a quick release mount. We've then built out this nice little power and data breakout board. And this makes it really easy to route the connections from your gimbal through to the drone. And then also, everything is going over a dedicated power cable. So we're not having to deal with pushing a lot of current over small current lines. In terms of connecting to a video transmission device, there's a cable that is just really coming out of a USB to Ethernet connector, which I can show you down here as one use case. But the power and data breakout board that we have has a USB-A connector, and this is where you'll actually interface with, from the inside of the drone, the video feed. So there's some nice options there where you can actually plug in like a Wi-Fi dongle, which is like one of these alpha dongles, and then you can view those streams over Wi-Fi. If you'd like, another alternative is to actually plug that into a HearLink device or a Doodle Labs radio, or use a micro hard radio or similar. So on the flight controller, we tried to make it as simple as possible. The only things you need to run and interface with this gimbal are an RC that's coming from whatever controller that you want to use. In this case, we're using an HearLink V1.1 with an S-Bus coming in. This is coming in from the S-Bus 1 on HearLink, and then we're passing this RC through the TLEM port. That's coming through TLEM 2 for MAVlink control of the actual gimbal. Now, this is super nice with the MAVlink because it allows you to pass really any RC protocol that the flight controller accepts into virtual messages through the MAVlink communication. And you can do that with MAV-ROS, MAV-SDK, all kinds of different options for that. Andrew, in terms of connection to a video transmission device, this is the USB coming out of our gimbal going into a HearLink V1.1 Ethernet port. So we're really happy about this integration. It makes it very, very clean. And what you get is all that RTSP stream is being fed over the HearLink through their video stream. Here's some PX4 parameters that we're setting up. What we're doing here is we're setting our MAV1 config as TLEM1 and our MAV2 config as TLEM2. So if you were to use MAV-ROS with this, you can interact with these different configs very, very easily. There's a couple different mount modes that we recommend. What this does is essentially defines how your RC is controlled. And then if you're not familiar with MAVlink protocol, camera protocol, it's pretty awesome. It allows for digital zoom. It allows you for doing little widgets to actually move the camera around through the gimbal controller here. So you can do gimbal protocol that actually works with the MAVlink camera protocol. And it's very powerful. Really just starting to touch the surface on using it, but it's made integration super clean. In terms of the RTSP stream that's being spit out, what we're doing is they're going over two different ports. We've set a static IP for this gimbal. So the way that you're going to actually view and interact with the RTSP stream is just going to be through two different ports with a live URL. Once you plug all this stuff in on a HearLink, you're going to just view the fly view right. You're going to be able to view the video stream right on the fly view. It's really nice to have MAVCam Manager because you can switch between the different fly views, and it routes essentially each one of these RTSP streams to a different camera stream, and then in the fly view allows you to easily select it. So in this case, you can move between a thermal and an electro-optical sensor very easily. We're actually using an open source gimbal control board on this called Simple Base Cam, and it allows you to do anything that you want to do with the gimbal. So if you want to go in there, you can change anything you'd like. What we've set up within the architecture here is there is a MAVlink, a tunnel that goes through the actual flight controller. So as long as you're connected to a flight controller with this gimbal system, it'll route all the messages through from the actual gimbal controller and give you access to this GUI. And that's going to allow you to do all kinds of different things. Within this GUI, you can set up follow mode on the gimbal, or you can just let it get taken over by MAVlink and do MAV mount commands, whatever you'd like to do. You can go in and you can retune the gimbal if you added some weight to the gimbal, if you wanted to modify it. These are all options. We're leaving everything wide open. In terms of the companion computer can be accessed over SSH through that same USB connector that you can plug into a video transmission device. You can also plug directly into it with a USB-C connector. And this whole entire gimbal is really powered by the Voxel SDK, which is very, very powerful. It has the whole Voxel 2 mini system image on it. And that's going to allow you to interact with ROS2, Python 3, OpenCV, TensorFlow Lite, and a bunch of other really great software. And then here's just some general dimensions. These are, again, very preliminary dimensions, but it gives you an idea of what we're working with here. It's about 133 millimeters by 117 millimeters. A fairly small form factor, we like to think. And then there's a USB-C port here for actually accessing the companion computer. So I can reshare that and access any of that information if you guys would like to look at any of that stuff in detail. Happy to share this with any of you who would like to see the document further as well.
All right, thank you so much, Aaron. I guess we can in the ROS Discord thread we can mention that you guys are looking for beta testers, so that they can contact you if they want to have a preview of the hardware. I'll just start off with another question. Maybe that's kind of like a very big scope because I didn't see that yet in here. But are you guys at one point planning to add an event camera, perhaps?
An event camera?
Yeah, it's probably very broad. Let's say for the future, maybe a Raven 2 or 3.
Yeah, what is an event camera?
Ah, okay, yeah, it's a special kind of camera that actually it has a very quick refresh rate, but the thing is that you only see the changes, let's say, in the camera. So it's actually a very specific sensor, but there have been a couple of research out there. But I'm very bad at explaining exactly what it is. It's great for optical flow and thing control. Yeah,
oh,
Andrew,
like a
thanks.
global shutter. Is it a global shutter camera?
No, I don't think
Okay.
so. But I think, Andrew, you've sent a YouTube explainer of what an event-based camera is. I guess I'll just leave it up to you to check it out then. It's very cool technology, and it's at least in the academic field, there have been a couple of papers of drone racing with event cameras as well. So, does
Absolutely.
any
Yeah. But any of the image sensors that Modal AI supports, Modal AI is one of our partners. I see Andrew on here. Andrew from Ascend Engineering, another one of our partners. If people need help with software development, they're the guys to know. So if Modal AI offers a sensor, the integration path for this is very, very simple. We have integrated time of flight sensors, which will give you a point cloud. It looks pretty similar to those event cameras, right? And then there's ability to integrate tracking cameras and a couple different thermal cameras. So the challenge right now with the MIPI-based integrations is the driver support. However, this also is available for a as a USB-C camera, or sorry, as a UVC companion computer, right, where you could plug in any USB camera. So the other piece of this as well is that, yeah, really any USB image sensor would work. What are the form factors of those, Kimberly?
Well, they're definitely too big for a crazy fly. That's one thing that's for sure. But they're relatively quite new image sensors. I think the form factor has been that they managed to get it like maybe to like a form factor of this size. But that's kind of like the same image sensor stuff. I have no idea about the qualities of the lens, to be honest. And when my lab was working with it, like still back at TU Delft, it was really a camera that was about this big, and it was without the gimbal. So, Yeah, but I guess I'll ask Andrew indeed about that. But it seems that he shared he just shared a YouTube video on the chat that I will also share in the ROS discourse later. Anybody have any other questions for Aaron, just specifically about the Raven 1 and the specs that he's shown? No? Anybody that's willing to be a beta tester?
Are you guys planning to ship it to Poland across the ocean? I would love to test it, but it's far away, kind of. So.
No, I think we can definitely ship internationally. I think most of what we are working with here is okay to ship. The thermal cameras may need to reduce frame rate to certain countries, but we can definitely talk.
Yeah, is it possible to use just a gimbal with any other sensors? For instance, let's say IMX, some IMX type of sensors.
Yeah, absolutely. The sensors that are actually on here are IMX, sensors.
Okay. But you can change it, right? I mean, let's say if we need to change it, it is easily, let's say, replaceable with this gimbal setup, right?
Yes and no. We're trying to go through the architecture of that in terms of how you would modify the configuration of the actual image sensor setup. One of the finicky things of gimbals is the balance needs to be, quite perfect, right? So the issue with modifying the image sensor, if you were to put in a different one, is that you need to change the faceplate and it kind of modifies the balance. So we're trying to figure out how we can best offer this for integrators where they can change out the image sensors without having to buy a completely new gimbal. You can imagine it, if you were to make the gimbal housing attach, then the companion computer would need to come with the entire set of image sensors. So Sama, to answer your question, again, any of the image sensors supported by Modal AI are very easy to integrate with. They have
Got
an
it.
IMX 678 and an IMX 412.
Got it. So we yeah, actually, so we are using IMX 412, which is actually a Model AI drone. Sorry, provided by Model AI. So, but we are trying to do some modifications in the Model AI setup based on you can say based on the requirements for the image capturing or image or for the images we have. So that's why we are exploring some of the gimbals. So having said that, is it possible if if we could get, let's say, at least the technical specs or the data sheets for the study these gimbals, or when you are going to plan what are your plans for launching this product?
Yes, sir, Selma, we can definitely get you the spec sheet. Plans on launching this product are hopefully by the end of this quarter. We'd
Okay.
like to have a fully built out version. What has paused us from launching is completely honestly the fact that we had a complete IMU based setup, and it just, the encoders are somewhat necessary for a flying gimbal, right? So we went back to the drawing board. We're releasing the next version is just going to be fully encoded.
Got it.
So that should be within the next 2 months. We hope to have that for sale. If you want to be a beta tester, it's pretty much ready to start shipping to beta. We just would need to know what requirements you had if they were different than where it's at. But currently,
Yeah,
it's shipping with the IMX 412, which
got
isn't
it.
right. It's not the highest end sensor, but it has a very, very low latency. So if you did need a higher megapixel sensor, what we can do is we can integrate that over USB with you. And it would have to be a custom build, but we can leverage the same architecture.
Got it. Yeah. Definitely we would proceed for the beta testing, but we at least need, that's why I requested for, if you can share us the data sheets. We actually want to look more into the depth of especially about the gimbal. Then we can, let's say you can further research that if do we need to change the camera or not, do we need to, what we're gonna be, our next steps would be. So,
yes, sir.
Yeah,
yes, sir. Yes, sir. But the goal is to provide a really nice open source architecture that the community understands and can build off of, that has the gimbal controller, the MAVlink, and the companion computer, and you can choose the image sensor if it's not good enough. But we hope,
Got it.
we hope everything down the line that we can provide a platform for that.
Got it.
So
Understood.
yes, I will. I'll get your contact info, Osama.
Yeah. So yeah, if you should I share here something like email or something, or how I can contact with you?
Yeah, would you, if you don't mind, shoot your email in the chat if that's okay with you.
All right.
Thank you.
Okay. Well, I think we really have to get the meeting going. So if everybody could give a clap emoji to Aaron Blues for his presentation of the Raven 1. Thanks again, Aaron, and we'll continue with the meeting now.
Thank you.
All right. So just to also kind of like a big first a quick look at the aerial robotic landscape. If you haven't heard of it, it's a website that we maintain. There, anybody can add info about anything aerial robotics. It's an info hub with useful links to courses, hardware, etc. So I can also kind of like very quickly show a view of it here. One moment, if I can find it. I am having some. Let's see, presents this one instead. So here I can go very quickly see. And so it has also got all kinds of useful links about aerial vehicle types, simulation, hardware components, autopilot suites, hardware as well. So the Raven 1, we should definitely add to that as well, to like at least like interesting components. So that is something that we should definitely update with the content of the presentation. So since July, because we haven't had a developer meeting for a long time, there were some extra courses added. We have the autonomous mobile robotics that was added. We also have added the IEEE ROS Summer School for Multi-Robotic Systems from the Czech Technical University of Prague, which is every summer, I think around August. New hardware has been added, the Fly for Future RoboFly, and they also do custom drone designs. New autonomy stack. I think Manola, you added that one from I think DocuDrone, Pi drone packages. Unfortunately, there were also a couple of links that were broken. So the Holybro X500 V2 and the UVFly UVFi has been removed. Unless you guys say, hey, that's still being sold, don't remove it. Let me know the updated link. But at least that's the newest update for now. I'll very quickly share also the link on the chat so you can have a little look for it yourself. There you go. Yeah, so just first of all, like this community update. So because we haven't actually had a developer meeting for a long time, unfortunately, I don't see many people of the original subcommittees in here. But anybody can just show their hands, just like, okay, what kind of projects have you been working on during the summer and September? Please raise your hand if you like to kind of like tell us a little bit about something. Not everybody at once. Yeah,
I guess Oh, sorry, just went ahead and spoke.
Yeah, it's Alexis was first. So could you share first, Alexis?
Oh, sorry about that. Oh, glad to see you again. I've been looking for different tools to add into the Mac Docs installation that we place in there, and still like doing some experimentation during the summer. I would like to share some of that later, but for now, just know that I'm working on it still.
All right, thank you. Yeah, just the background information. MK Docs is the kind of the backend of the website that we just saw. It's a really nice tool to generate websites. Definitely recommend that. Davide, go for it.
Yeah, I wanted to show a sneak peek. We've been working on this new drone, and I think we have a presentation scheduled for next month with us.
Yeah, it's like that's the is that for the DocuDrone? Yes,
Yeah, correct.
the DocuDrone, the new DocuDrone. I forgot the name. Is that 24P? Yes.
Yeah, the DD24. I can show you a little video of how it was like flying it around. Let me see.
Yeah, I'll unshare my slides. Just a little teaser for next meeting.
Yeah, I've been having quite a lot of fun flying this thing. Can you see my slide? Yeah.
Yes.
Yeah, we have this thing flying. Right now we have altitude control working, and we're gonna get also like the velocity and position control to work appropriately.
Ooh, I see some texture on the floor.
Yeah, that's for the optical vision stuff.
Yeah, I'm very familiar with those. But natural texture works the best. Awesome, cool. Looks really cool. I'm excited for that presentation. Let's see.
Yeah, I'll try to carry one with me at ROSCON to show you.
Oh yeah, absolutely. We'll let's start. We have a flight cage there, so you can try it out in there. Not sure about the texture though, because we're going to use the lighthouse system ourselves. But
I see.
yes, very cool. Anybody else want to share anything that they've worked on, or any cool projects, or yeah, or want to kind of share like if they want to give a presentation at one point? That's also like the video will in about a month. All right, Andrew, go for it.
Yeah, it's a project I haven't started yet, but I've been looking at doing is the so the company Prophecy, they released an evaluation kit for an event camera. It's for the Xilinx board, and so I've been talking with Alexis about maybe getting some basic project working, but it's it's going to be a difficult project because it's still an evaluated product. It's not a production release of the software architecture is just hard to figure out, and of course the Xilinx board doesn't make anything easier. But yeah, I think that's a project I want to start and see where we go.
Very cool. I guess you're familiar with the work of Davide Scaramuza at ETH or the University of Zurich.
I've seen his work, yeah, but I haven't been able to dig deep into it. It's something I just started looking at.
All right. Cool. Great. Awesome stuff. Jacob.
Hi, this is actually here with Jacob. He and I are students at Robotics ROS flights. Bringing up for ROS2, hopefully autopilot for big solid runs. We're all doing stacks for 50 and advanced, and we'll
Jacob, you're very difficult to hear you for some reason.
Sorry, I have a connection. Can you hear me?
Yeah, no, it's I don't know. There's something wrong with your microphone.
we're looking at something like this.
Yeah. All right. Maybe perhaps you can share the update in the chat and I can read it out perhaps. But it's yeah. Unfortunately, it was I heard something with ROS2 somewhere, but yeah, no, the microphone was too bad. So next, you can share the next time if we have another meeting. Anybody else want to share? No? I think it's probably good to also mention that Ryan has also kind of like started a pull request on the REP 147, which is the kind of like the ROS message standard. It's not like the official ISO and open standards in aerial robotics, but it's the one that ROS uses to have a geopost stamped in there. So if you want to help out, go for it and help them out with the pull request. I will share the link in the chat right now. Check. And Jacob has sent in like, okay, yeah, so Jacob is saying they're working on ROS flight on ROS2 and autonomy stacks for fixed wings, multi-rotors. Check us on rosflight.org. Very nice. Are you guys on the aero robotic landscape already? I think you are, maybe. Let's see. If you're not, please add yourself. So that more people know about you. All right, cool. Like I think it's now time for a bit of a bigger announcement. Like unfortunately Ramon was hoped to be here at one point, but just to talk about like the let's say the Aero ROS meeting in general. Like we have been doing this already for like almost like a year and a half. But we had a long summer break and we had a chance to think about things and came up with a new format that will allow us to impact the community more of kind of like in a direct way perhaps, and kind of restructure it as well. So we would like to shift the meeting from bi-weekly to once per month. So that is will help us to be a bit more effective, prepare more also. So that will at least be the biggest change so far. Also, we're thinking about doing like a new meeting format. We used to have bi-weekly, like a developer meeting, and the 2 weeks after we had a presentation meeting. So the full meeting will be a presentation. We would like that to be more like a hybrid, like half an hour for open source projects and companies that support the aerial robotics community, give them a platform for a presentation. And also the second half of the meeting will be about community updates and announcements, also focusing on the aerial robotic landscape and updating that. Unfortunately, yeah, there's not a lot of people that were part, or at least were leading the subcommittees. I guess like except for Alexis for the documentation was at least helping me out. But we couldn't really find a way to keep the committees really engaged and focused. And we couldn't really find any more contributors to really pitch in. So it was an increased workload on the planning and direction. And in this case, like we would like to stop the subcommittee formats for now. So then in that sense, yeah, we want to thank like all the committee members from you, like, you know, all your trust in encouraging us to look into your projects, and that you've already helped. You guys helped a lot with forming the aerial robotic landscape with a lot of content. And I think in that sense, it was definitely a success. But the subcommittee, we don't have enough content, or not enough. We have plenty of content, but we don't have enough people just to have 4 different separate directions. It would be nice to just concentrate those efforts. Also, it's also very important to know is that we are just a humble, like, you know, community interest group for ROS. Like from like the new structure of how the Open Source Robotics Foundation, we are not actively part of the actual ROS framework, and nor can we really actively shape the direction of the ROS framework. That is really a individual contributor task to do. So all of you guys can do that. Like for instance, like wow, Ryan has been doing it. But we will do our best to promote all of your robotics work that is done by you. And also, me and Ramon will remain available to each of the members or like people that join here, and to offer you guys like mentorships, for instance, to help you succeed, like at least like in your robotics and open source journey, and of course also to connect you with any of our network, the people that we know in our network that we think is a good fit for you to help you with your projects. So yeah, that's kind of, that was at least the announcement. I hope. Are there any questions about this? Any thoughts or worries? Or yeah, Alexis?
A question about the Discord server. Is going to be still at the Open Robotics server, or it's going to be moved somewhere else?
No, the Discord's the Discord's channel, this S.W.A.P at Ariel, for our, like, it's still going to stay there. Like, we haven't had any word from the Open Robotics that they want to remove that. So that will be still at the Open Robotics server. For the time being, until they say they don't want to do that anymore, then we'll change things, and we'll start our own server. But for now, we're going to continue to be on that. They haven't kicked us out yet, so let's use it.
Okay, yeah, I was thinking of that because of that point that you said that's only on a community group, and it was like, yeah, but we for sure need a place to share information and to coordinate for meetings and stuff.
Oh yeah, absolutely. And I would also prefer to keep the, like, I like doing the Discord. It's a very easy way to just quickly share information. So like, personally, I would definitely want to keep that open. Yeah, so let's see. And if they don't like that, like if that's not going to be the case, then we're definitely going to have an alternative and share that on the ROS Discord or any of the other meetings. Yeah,
perfect.
That's a very valid point. Thank you.
Thank you.
Yeah, in terms of the communication channels, we're just still going to use ROS Discourse and Discord. So there's no change in that. Any other questions or comments on this? I see that Ramon is able to join us. I'm not sure if you're in a position to add anything else to the announcement I just made. But okay, yeah. Like I said before, he's probably on his way to an appointment. So, all right, I guess it's all clear for now. Like I said, we're definitely not canceling the meetings. We're still providing the platform there. We're just going to change the format. That's going to be more suitable for all of us. Yeah, so that means that the next meeting will again be a hybrid meeting. Like both a presentation and developer an update meeting, like I explained in the announcement just now. So it's going to be either the 6th or the 20th of November, because now it's going to be every month. But it really depends, because Davide, when do you want to give your presentation? Because we can also determine that on that.
Yeah, I think the 20th is good.
Yeah. Okay, then the next meeting is going to be on the 20th. So on the 6th, we're just going to skip it, because we're also going to have the Aero Robotics meetup at ROSCON. So technically, that's going to be a mini meeting anyway, for those that are involved. And yeah, it's going to be the new DocuDrone. So yeah, definitely shouldn't miss that. So the GitHub organization for this working group is github.com/ROS-Ariel or ROS-Ariel. And like I said before, also, if you want to add any info page you like on the Aerial Robotic Landscape, this is the way how to do it. It's all hosted on GitHub, so you can very easily change the source of that. So you can add any cool projects you've seen or cool hardware. And we definitely have to add the Raven one. Thanks a lot also again to Aaron for giving the presentation. And yeah, have a very good day or evening. Thank you.
Thank you all very much.
Bye. Have a good day.
Thank you, Kimberly.